right, we're in section 1.5 where we are going to describe angle pair relationships. So there's different terms that we're going to look at when we're dealing with different um, angle relationships. So we have some more terms to look at. The first one that we have up there is complementary angles. Complementary angles are two angles where the both of the angle measures their sum is 90 degrees. So they could be two separate angles. They could be angles that share a common endpoint, whatever it may be. Same thing goes for supplementary angles. The only difference between that is those two angles, their sum measurements are 180 degrees. Next one is we have adjacent angles. Adjacent angles are two angles that share a common endpoint inside, but have no common interior points. It says two adjacent angles are a linear pair if their common sides are opposite rays. So if you have essentially, if you have like a line, oops, if you have a line right here, and so this angle here, so we'll just say this is A, we'll call this B, we'll call this C, and then we'll call this point X. Point X is um, common vertex, and A, X, C are collinear. They're an opposite line. They're opposite rays. We can then say that they are a linear pair. Two angles are vertical angles if their sides form two pairs of opposite rays. So basically it means anytime you have vertical angles, it means they're equal. And uh, if you have two opposite rays, so I have like this line and it intersects this line right here. So the opposite one would be whatever this angle is. This one's going to be the same, or whatever this angle is going to be the same as this angle. Those are the vertical angles. All right. So we have a series of angles with measurements given to us. So they're asking us to name the pair of complementary angles and a pair of adjacent angles. So complementary angles by definition up top is anything that adds up to 90 degrees. Well, I look at 38 and I look at 52, that adds up to 90. So I can say that angle A, B, D and angle B, D, C are complementary. All right, so remember how I named it, vertex, vertex in the middle. Adjacent angles, all right, so adjacent angles are any angles that share an endpoint. I want to make sure I'm saying it right. Adjacent angles are two angles that share a common endpoint inside, but no common interior points. So right here, we can say that angle CDB and angle BDE are adjacent angles. So they share a common endpoint, no interior points. All right, here they want us to name all of the linear pairs. So all the linear pairs here, like they say, they're adjacent angles, but they have opposite rays. So I look here, angles 1 and 2 have opposite rays. Those would be in a linear pair. So angle 1 and angle 2 would be a linear pair. Also, I notice that 2 and 3 are opposite rays. So I can say that angle 2 and angle 3 are a linear pair. Are there any others? Um, I don't see any. I could make up a sum of them that would make up a linear pair, like 3, 4, and 5, but pairing is usually 2, so that's where 1 and 2 are linear pairs, and 2 and 3 are in fact linear pairs. Here they want you to name all the vertical angles. All right, so there's only one set of vertical angles, and that is angle 1 and angle 3. So right here are the vertical angles right here. So we have those, whatever those measurements would be, they'd be the same because the line is at the intersection of two rays, or whatever this point is. There makes up opposite rays, and we can't use any of the other ones because we have this ray that's independent from everything else, and we can't get any measurements from that. So those are the only set of vertical angles. All right, here they want us to name all of the adjacent angles that are not also linear pairs. So the ones that are not linear pairs, so you can say that angles 1 and angle 5 are adjacent angles. They're not a linear pair. You could say that angle 5 and angle 4 are adjacent angles and not a linear pair. We could say that angles 4 and angles 3 are adjacent angles that are also not a linear pair. Okay. So now here, these questions pertain to this diagram here. We have a series of endpoints with angle measures attached with them. So they want us to name a pair of complementary angles. So I see I have 40 and 50, that adds up to 90. So I can say that angle DEF and angle ABC are complementary. So next thing is supplementary. Supplementary is 180. I see I got 140, 140, and 40 give me 180. So that fits the description or fits the definition. Angle FEG and angle ABC are supplementary. And then finally it says name a pair of adjacent angles. So naming a pair of adjacent angles, I could say that we'd have to use this one here because there's just only two sets of rays. So this angle here and then also this angle here are in fact adjacent angles. So got to clean it up a little bit. We can say that angle GEF and angle DEF are adjacent angles. Here they want us to identify all the linear pairs. So by definition, linear pairs, it says they are adjacent angles with their non-common sides or opposite rays. So trying to identify anything here that has opposite rays is you can't because you got 3 and 6. Those are they're not opposite. So well no, I'm sorry. We have linear pairs is anything that so like this would make up a 180 or this would make up a 180, but it requires more than two angles to do it. So to answer the question, there are no linear pairs in this diagram, but there are in fact vertical angles. So there's actually three pairs of vertical angles. Angles 1 and angle 4 are vertical. Angles 2 and angles 5 are vertical. And angles 3 and angles 6 are vertical. All right, so it says here, given that angle 1 is a complement of angle 2 and the measurement of 2 is 57 degrees, they ask us to find the measurement of 1. So complementary means 90. So we can say that 90 is going to equal 57 plus whatever the measurement of angle 1 is. So we can take 90 subtracted by 57, it gets 33. So 33 degrees is going to equal the measurement of angle 1. Here it says that angle 3 is a supplement of angle 4, so that means 180. And the measurement of 4 is 41 degrees. I want us to find the measurement of angle 3, so I go 180 is going to equal, all right, so I got 41 plus the measurement of angle 3, 180 minus 41 is equal to 139 degrees, so that's going to equal the measurement of angle 3. Here it says angles 1 and 2 are complementary, measurement angle 173, find 2. So again, complementary is 90, so just go 90 equals 73 plus the measurement of angle 2. 90 minus 73 equals 17, so I got 17 degrees is equal to the measurement of angle 2. And given angle 3 is supplementary angle 4, so that's 180 again. Measurement of 4 is 37 degrees. Find measurement of 3. So we got 180 is equal to 37 plus measurement of angle 3. 180 minus 37 gives us 143 degrees, and that's the measurement of angle 3. So here we have, it says a basketball pole forms a pair of supplementary angles with the ground. It says find the measurement of angle BCA and the measurement of angle DCA. So they're telling you that these are supplementary angles. That makes sense because they're also a linear pair. So uh, anytime we have a linear pair, their sums are going to equal 180 degrees. So keep that in mind. So now we want to find the measurement of BCA and DCA. Well, they just told us they're supplementary, so we can say that, all right, BCA is 3x plus 8, so I'm going to say 3x plus 8 here, plus DCA is 4x minus 3, and that's going to equal 180 degrees. Like terms here and here, 7x, like terms here and here, plus 5x is going to equal 180. So I got 180 minus 5. That gives me 75. So now I got 7x is equal to 175. Divide that by 7. I get x equals 25. But again, it didn't answer the question. It just allowed us to find a value for x that'll help us find angle measurements of BCA and measurements of DCA. So I can look over here and say, all right, I got 3 times it by 25 plus 8. So 3 times 25, 75 plus 8 equals 83. So this is 83 degrees BCA. And I can go 4 times 25, write that down, minus 3, and 4 times 25 is 100. Subtract that by 3 is 97. So I got 97 degrees here. And if I took 83 and added it to 97, you should get 180, which you do. So that's another way you can check your work. Here it says, suppose the angle measures are 5x plus 1 and 6x plus 3. They want us you to find the measure of BCA and DCA. So I'm guessing it's the same diagram. So same idea. They were supplementary angles, so you got 5x plus 1 plus 6x plus 3, and that's going to equal 180. Like terms here and here, so now I got 11x plus like terms here and here. I got 4, and that equals 180. Subtract by 4, I got 11x equals 176. And if I divide that by 11, I get x equals 16. So we found x. Now we have to find the angle measures. So here I can say that this is 5 times it by 16 plus 1, and over here this is 6 times it by 16 plus 3. So looking at the first one, I got 5 times 16 equals 80 plus 1, which is 81. So this is 81 degrees. And then 6 times 16 is 96. Add 3 to that, I get 99. So 99 degrees here. Add them together, you should get 180 as a sum, what you do. So here it says we have two angles form a linear pair. Okay, so anytime I see that something forms a linear pair, I always know that they are supplementary. So I always know that they're 180 degrees. The measurement of one angle is 4 times the measure of the other angle. Find the measure of each angle. So I got a linear pair, so draw it out. So I got my linear pair right here. So they say that one angle is 4 times larger, so this one appears to be the larger angle than this one. So let's just say that whatever this angle is, we're going to call it x. This is 4 times that measure, 4x. So since they gave us the information that it's a linear pair, we know that the sum of these would be 180 degrees. So 4x plus x is going to equal 180. We have like terms here and here, so this is now 5x equals 180. So we divide everything by 5, which then gets us x equals 36. So we found our first angle measure, which was 36 degrees. And then to find the second one, we just take 36 and times it by 4, which is 144 degrees. Last example, it says we have two angles form a linear pair. The measure of one angle is 3 times the measure of the other angle. They want us to find the measure of each angle. So we go here, linear pair, 3 times. So we got our linear pair right here. We know that the linear pair is going to measure out as a sum of 180. We don't know what this measurement is, but all we know is whatever that measurement is, it's 3 times as much as the other angle. So same idea, 3x plus x is now going to equal 180 degrees. Like terms here and here, 3x plus x is 4x, so 4x is going to equal 180. I take that 180 and divide it now by 4, which now gives me x equals 45. So I know my two angles in this particular example are going to be 45 degrees and 45 times 3 degrees, which is 135 degrees. And again, if you added them up, 135 plus 45, you should get 180 degrees, which you do. And that is being able to describe angle pair relationships. Hope this helps. Till next time.